really what we need to do is we need to move from factoring regular numbers like we have been doing in 3.1 and 3.2 to taking a look at polynomials. So now we're looking at expressions with one or more terms, and those terms could involve variables like you see here. Okay, so we know that numbers, regular old numbers, can be factored into prime factors such as 12 is 2 times 2 times 3. But what about monomials? Okay, first of all, monomials, the root there is mono, which means one. And when you have this meals right here, that's the part of the word of polynomials, okay, or nomials even, polynomials. So we're talking about terms, either one, which is a monomial, two terms, which is a binomial, three terms is a trinomial, and so on. And those involve usually numbers here, maybe fractions, maybe decimals, and also a variable or two or three or more. And each of those variables can have exponents on them. So these are example of a single term, one term monomial. All right. Now what you want to notice is it looks like there's two separate things here, right? But it's still one single term because they're multiplied together. Okay? So 12x to the fourth is a monomial. Now can we factor, like completely factor into prime factors, this monomial? Well, if you look at 12, 12 can be factored to 2 times 2 times 3, as we know. How can I break down and show x to the power of 4 in its prime factors? What does that look like? What does this mean? Let's think about that. X to the power of 4. What does that mean? Can anyone tell me what that means? Yeah? X times x times x times x. That is exactly true. So if we showed that, each x there would be its prime, the prime factor of x to the fourth. So this is how we could prime factorize 12x to the fourth. What about 10? How do I show 10 as prime factors, or 10a squared b squared? Well, we have 2 times 5 times a times b times b. 2 a's multiplied together and 2 b's multiplied together. Okay? So the first step in factoring monomials and factoring polynomials is to notice and to see and understand that this is what we're looking at. So what we can do is we can take a look at monomials and we can completely factor them. So why don't you just take an opportunity here, take a minute and completely factor those 4 monomials, actually the 3 monomials, and then I have a binomial here. So I want to see if you know how to do this one. I haven't told you how to do this one yet, this D, but I want you to try and factor each of those. Tell me what you can come up with. Okay, give that a shot here. I'll give you a minute to do that. All right, so when you're done, have a look at the board here and just check to see if we have the same things written down. Okay, so in this completely factored to prime factors, if we're doing that for these monomials, you're going to want to show both the number and the variable parts as prime factors. Okay, so it should look something like this. Now I didn't do D because I kind of wanted to hear from you guys. Did you do each of these separately, or did you combine them in any way, or does anyone want to share real quickly how they kind of went about that? That's fine if you don't. Yeah, you can. These are added together. So what this means is there are 2 terms. This is a binomial. Okay, it's a binomial. There are 2 terms in this polynomial. Okay, in this expression. And oftentimes I'll refer to them as expressions. So if we do that, let's prime factor each of these. So 3 times x times x. That's going to be the first one. Plus 3 times 2 times x. Or let me just rewrite that here because I'm going to come back to it. Let's go 2 times 3. 2 times 3 times x. Okay? And if you spread it, factored it out like that and left that as an answer, that's exactly what I was looking for. Okay? Now we're going to come back to this very quickly. Okay? We're going to come back to this very quickly, and we're going to see what we do with multiple terms when we're trying to factor. And again, taking a lot of time on factoring because it's probably the most important skill in all of high school and university level math. It really is. If you can't factor, you're not going to get anywhere. So it's very important. Okay, let's change gears a little bit. Let's go back to multiplying. Okay? Do you know what happens when you have something like this? Do you know what the answer is when you have 3 times 4x squared? What's the answer? Just go ahead and shout it out if you know it. 12x squared. Very good. That is absolutely correct. What happens if I have something like this? 2a squared times 3b squared. If I multiply that together, what do I get?
6a squared b squared.
Okay, so you take a look at the numbers and you multiply those, and that's 6. So the number part is 6. When you take a look at the variables, you multiply those as well. So really, those are different terms, so we can't combine them in any way other than just to show them as multiplication. That's totally right. What happens when we have something like this now? Okay, so 4a squared b times 2ab cubed. Okay, so now we're getting somewhere a little bit deeper here. What is the answer to this one? Anyone figure out the answer to this one just in your head or? Sorry? 8a cubed b to the 4th. That's exactly correct. Now how do we get that? 4 times 2, that number part is 8. And then what you do is you look at the variable a and you ask yourself, is there an a in the other part? And there is. When you multiply powers with the same base, you add the exponents, which is exactly what you did. So that's going to be a cubed b to the, well, let's see, that's 1 plus 3 is 4. So when you multiply powers with the same base, you add the exponents, right? So a squared times a to the 1 is a to the 2 plus 1, or a cubed. Okay? So that's something we're going to go over. I think that's coming up again. I think we're going to talk more about that. Yeah. In next chapter, later in this chapter, we're going to be working on exponent laws again. But it is important to know the basics here. Okay? All right, so let's go up one more level then. Let's go up one more level. When I multiply 3 times x squared plus y. Okay, so now I'm doing a monomial times a binomial. Who remembers how I approach this? Okay, so the answer is you're saying 3x squared plus 3y. Okay, so can you tell me how you got that? Okay, so you take this in the front and you multiply it by each thing. So by each term in the binomial. And that is exactly right. This is called distribution, or the distributive property, okay, of multiplication. You're exactly right. So we take whatever's in front, especially if it's a monomial, we multiply by all of the terms inside. The first multiplication, you write that down. And then the next multiplication, you write that down as a separate term. So this would be positive 3 times positive y, which becomes positive 3y. Very good. That is exactly right. Okay. I'm going to step it up just a little bit here. 2x squared times 3x minus 4x squared y. Okay? So let's follow along that same method, which you're exactly right. This is a monomial out front, so that's just a monomial. So let's distribute inside the brackets to each term. So 2x squared times 3x is going to be, 2 times 3 is 6. X squared times x to the 1 is x cubed. Very good. That's going to be the first term in our product. The product is an answer when we multiply, of course. And so now we do the next distribution there. And this is where you have to be careful with your signs, okay? This is a positive 2 when we're multiplying by really a negative 4. You have to consider this minus sign. So positive times negative is negative. So that shows up as a minus, okay? And yes, this means we have another term coming here. So a second distribution, a second term. So that's going to be minus 8 x to the 2 plus 2, 4. And then y, well, we only have one y, so that y just stays there. And does that look like it's the solution there? The product, everyone good with that? Okay. All right, so why did we do that? Isn't this about factoring? Why are we multiplying? Because factoring is just doing the exact same thing that we're doing here, but going backwards. Okay? We are now going to be looking at a product like this right here. Let's just erase this. We're now going to be looking at a product here, and I am going to try to factor it by looking for a greatest common factor of the two. Okay? So let's go back up to this example right here. Okay, you see this one? Now, in these two terms, which basically is 3x squared plus 6x factored, fully factored, do you see a greatest common factor that exists in both of those terms? So, just like we've been doing, what's common to both terms? Well, I have a 3 as a common factor. Do I have anything else that's the same in both terms? I have an x as well. Does everyone see that? Now, there's not another x in both terms, okay? There's not another 2 as a factor in both terms. So now I've just highlighted everything that is common. So guess what? This can be written as a product of the greatest common factor times whatever is left over once it is removed. So watch how this works. I write the common factor, which is 3x. And then I use a bracket to signify I'm multiplying by whatever is left over. What is left over? And it's really easy to see. What's left over in the first term is just x. Okay, and I have a plus. What's left over here? 2. X plus 2. So, this expression right here factors down to this. So how many of you on a scale of 0 to 5 feel fairly comfortable with it? Or you've seen this before, you kind of get this. So 0 is I've never seen this before. 5 is I remember doing this, I'm pretty good at it. Somewhere in between is like I'm a little fuzzy. So let me see the fingers here. Okay, I'm seeing a lot of fingers up, okay? 0 out of 5 or 5 out of 5? Yes? 5. Okay, lots of fingers. Very good. Okay, so let's go back to this one. What's my greatest common factor? And you don't have to, but you can write this in as prime factors. You can, and I will just for this one. 3x times x plus 3 times y. Pretty easy, right? So what's common to both terms? Yes, just the 3. So here's the 3 and the 3. So I put the 3 out front. Is there anything else that's common for variables? No. So, guess what? I put what's left over. When I divide the common factor out from each term, I put whatever's left over back in the brackets. So that's going to be x squared plus y. And that's factored. Questions? Okay, go ahead and factor this one. Show me the factor for this one. And then if you got that one, why don't you do a couple more? And I'll throw in a trinomial. It's a polynomial with 3 terms. See if you can take a greatest common factor out of there as well. There's your first one. 4 is the greatest common factor there. Take a 4 out, you're left with an m in the first term and a 3 in the second term. Does that look right? Okay. What is the common factor for the next one then? Yeah, can 6 be evenly divided into 15 there? No, 15 can't divide by 6. So both of them can divide by 3 though. That is your greatest common factor. And there's no a in this term, right? There's nothing there. So I can't pull an a out. And you'll hear me use those terms as well. Pull a factor out. Pull a common factor out. So we've got 3. What's left over when I take a 3 as a factor out of 6? I'm left with 2. Good. Minus. And when I divide 15a divided by 3 to get that factor out, I'm left with 5a. Okay? Awesome. Okay, I think you guys are getting it. So what about this one? Let's go a little bit quicker. Between 6 and 4, is there a greatest common factor between 6 and 4?
2.
Yeah, 2. Not 3. That doesn't divide evenly by both, but 2 does. So let's pull a 2 out. Now what about the variables? Is there something common? There's a c in both. How many c's do I have in both? I just have one c that's common to both terms. Very good. So I'll pull that one c out. Now I put the bracket. Now I go back to the first term and say, okay, when I divide this common factor out, what am I left with?
3.
3. Minus, what's 4c squared divided by 2c? That's going to be 2c. Good. Now, do you want to double check to make sure you're doing this right? You want to double check the terms in the brackets here, like this binomial. If you see another common factor, that means you didn't take out the greatest common factor in the first step. No problem. You just have to take out another factor from that one and then multiply it with what you already have. But if you take out the greatest common factor, you won't have to do it again. But that's how you check. Okay, so the trinomial. There's nothing special about the trinomial other than you look for each of the terms, what's common in each of the 3 terms, and what would that be?
3.
Yeah, 3. You can take a 3 out of 3, out of 12, and out of 18. What about a variable? Should I put an a in there?
No.
No, because just the plain old 3 does not have an a. It's not common. Good. So, when I take a 3 out of this, what am I left with? 0? This happens a lot, okay? So don't let this happen to you. Some students say, oh, a 3 divided by 3, it's gone.
It's 1.
No, it's not gone. Yeah, it's 1. Okay? So please don't forget that. 3, when you take a common factor of 3 out, you're left with 1. All right? So I do this sometimes just to show, hey, I'm just dividing this term by 3. So I get a minus 4a. Right? And then this one is a plus 6a squared. Okay? Everyone see that? How can you check these? How can you check these? Because it is important to be able to check. Do you know how you check to see if you've got the right answers? Yeah, you've factored, you've broken down something into its factors. So now if you multiply those back together, you should get the original question. You guys see that? You should get the original question. So we have what? 4 times m is 4m. We have 4 times 3 is 12. Is that what I started with? Yeah, I'm good to go. This is still your answer. Right there. Okay? So if I multiply this in, 3 times 2 is what? 6. 3 times negative 5a is negative 15a. Is that what I started with? Yes. So that's how you check. You can just distribute. We'll do this final one. 3 times 1 is 3. 3 times negative 4a is minus 12a. 3 times 6 is 18a squared. Is that what I started with? Yes. So this is my answer. Questions? No? So once again, the question was, do you have to further factor within these brackets? Only if there's a common factor to all of them do you have to go further. So you do not have to do this. You don't have to say, hey, there's a 2a I can take out of there, and then further it. You know, you don't have to do this, plus 3a. You do not have to do that. Okay? Only if there's a common factor to all three do you have to break it down further. Okay? So that's a good question, though. Very good question. Okay, I'll give you your assignment. So just a reminder, you do not have to use algebra tiles here. When it says use algebra tiles, you don't. So just factor these just like we have just been doing. 7, 8, and then there's 10. Get some work with some trinomials there.